Hi, I'm Malcolm, and welcome to your first SIK with MicroPython circuit. In Project 1, we're going to be learning all about light. And in Circuit 1A, we're going to start things off easy by just blinking an LED. Since this is your first circuit, I figured it'd be a good idea to get started with a description of a breadboard. A breadboard allows us to easily assemble circuits by plugging jumper wires and electronic components into its holes. Each hole is on a number and letter grid, like the board game Battleship. So for example, B3 corresponds to this hole because it is in the B column and the third row. A breadboard is split into several sections. On the sides are typically the power and ground rails. The power rail on either side is marked with a red plus sign and the ground rail with a black minus sign. All holes in a given rail are connected. So all of these are connected. All of these are connected, all of these are connected, and all of these are connected. The middle part of our breadboard is divided into two sections on the left and right. The holes in each row of a side are connected. So all the holes here are connected, and all the holes here are connected, and all the holes here are connected. But the holes here are not connected to the holes here. We can use these connected holes to connect various components of our circuit together. And if you couldn't quite follow which holes are connected to which on the breadboard, don't worry. The guide for each circuit will tell you exactly where to plug in your components with a handy diagram and wiring table, so you'll always know where everything goes. They also have this nice green highlight that indicates which holes that are currently connected to something. If you want a more in-depth overview of breadboards, feel free to check out our breadboard guide from the link in the description below. Now that that's out of the way, let's dive into our first circuit. For this circuit, you'll need an LED, a 330 ohm resistor, and two jumper wires. And our job is to figure out how to put them together to blink the LED. At the core of every circuit are voltages and currents. When there is a voltage difference between two connected points in a circuit, a current will flow between them. Our LED is polarized, meaning it has a positive side, which we should connect to a high voltage, and a negative side, which we should connect to a lower voltage, so that current can flow through the LED and light it up. The shorter leg of the LED is the negative side, so we'll connect it to the ground pin of our IoT breadboard, which is at 0 volts. The longer leg of the LED is the positive side, so we'll connect it to pin 34 of our IoT breadboard, which we can turn on and off with code. When we turn it on, it will apply a positive voltage of 3.3 volts, which is different than the 0 volts of our ground, so current will flow through the LED. We still have one last question to answer though. How much current will be flowing through the LED? Well, that can be explained by one of the most fundamental equations in electronics, Ohm's law. Ohm's law simply states that voltage is equal to current times resistance, or, said in another way, that current equals voltage over resistance. So far, we haven't yet added a resistor to our circuit, so the resistance is very low, meaning the current is very high. If the current is too high, our LED can get too hot and burn out. That's why we will add our 330 ohm resistor to the circuit. It will limit the current to protect the LED, while still allowing enough to flow that our LED is nice and bright. That's basically all the theory behind the first circuit. Let's build the thing. Remember to always disconnect your USB-C cable before you start assembling your circuit to make sure that you don't damage any of your components. For the first circuit, we'll connect the long positive leg of the LED to A2 on the breadboard, the short negative end of the LED to A1 on the breadboard, and the resistor from E2 to G2. Direction doesn't matter for the resistor because it's not polarized. Then we'll connect E1 to the ground pin of our IoT breadboard, labeled as GND, with a black jumper wire, and J2 to pin 34 of our IoT breadboard with a yellow jumper wire. Now let's run some code. If you missed our last video where we talk about the different coding environments, you can check that out here or in the description below. I'll be running all of my code in Jupyter Notebooks. Remember that to run a code cell, select it and press either Command and Enter at the same time or Control and Enter at the same time, depending on your platform. From the Jupyter Notebook site, I'll navigate to the Circuit 1A notebook. Next, I'll plug in my board and connect to it from the Jupyter Notebook. Now, I'll scroll down and start with this first code cell and run each code cell in order. Remember, you could also just hit this restart the kernel and run all cells button at the top instead if you wanted to run all the cells in order automatically. But sometimes it's nice to go one by one so we know exactly what each cell is doing. So first, let's press Control and Enter to run each of these first two cells, which are just set up for allowing us to control the LED pin. Next, I'll run the third cell, which sets pin 34 to 3.3 volts and turns the LED on. Let there be light. If we run the fourth cell, we turn the LED off because we set pin 34 back low. And now, I'll run the next few cells, which set up blinking the LED on and off a few times. And just like that, we've completed Circuit 1A. Take a break, check out the coding challenges, and whenever you're ready, check out Circuit 1B, where we dive into potentiometers and using one as a control knob for our blinking LED.